Grounding is connecting electrical equipment to the earth, providing a path for electrical current to flow during a fault. Bonding is connecting two or more conductive objects to each other to maintain electrical continuity. The size of the ground wire is typically determined by the ampacity of the circuit. For the AC unit feeders, if the ampacity is less than 65 amps, an 8-gauge ground wire is sufficient. Typically, the number of ground wires in a conduit should not exceed 4. In this case, having 5 8-gauge ground wires in each 3-inch conduit is not recommended. If the ampacity of the AC unit feeders is greater than 65 amps, a larger ground wire may be required. For example, for ampacities between 65 and 110 amps, a 6-gauge ground wire would be needed. It is recommended to use 8-gauge ground wires in the 1.5-inch conduits for each AC unit feeder. Use a 6-gauge ground wire in each 3-inch conduit to connect the 10 ground wires from the 1.5-inch conduits. This configuration satisfies the grounding and bonding requirements, with a total of 5 ground wires in the 3-inch conduits and an appropriately sized ground wire for the ampacity of the circuits. When dealing with electrical systems, understanding the difference between grounding and bonding is crucial for safety and proper function. Grounding ensures a path for fault current to return to the source, tripping a circuit breaker and preventing electrical shock. Bonding ensures all metallic parts are at the same potential, minimizing the risk of shock if a fault occurs. Let's delve into the specifics of ground wire sizing. The National Electrical Code, or NEC, provides guidelines based on the overcurrent protection device in the circuit. For instance, if the overcurrent protection device, such as a circuit breaker or fuse, is rated at 60 amps or less, an 8-gauge copper ground wire is typically sufficient. However, if the overcurrent protection device is rated between 61 and 100 amps, a 6-gauge copper ground wire is required. These sizes are detailed in NEC Table 250.122. Now, regarding the quantity of ground wires in a conduit, while the NEC doesn't explicitly limit the number of ground wires, practical considerations come into play. Overcrowding a conduit can lead to overheating and difficulty in pulling wires. It's generally good practice to minimize the number of conductors in a conduit to ensure adequate heat dissipation and ease of installation. When you have multiple circuits sharing a single conduit, each circuit must have its own equipment grounding conductor. This means that if you have 10 AC unit feeders, each feeder should have its own ground wire extending back to the grounding busbar in the panel. If the ampacity of your AC unit feeders exceeds 65 amps, upgrading to a larger ground wire size is necessary. Refer to NEC Table 250.122 to determine the appropriate size based on the overcurrent protection device. For example, if the feeders are protected by 80 amp circuit breakers, you would need a 6-gauge copper ground wire. Remember that these examples are based on copper conductors. If you're using aluminum conductors, the ground wire size will be different, as specified in NEC Table 250.122. It's also important to distinguish between equipment grounding conductors and bonding conductors. Equipment grounding conductors connect non-current carrying metal parts of equipment to the grounding system, providing a path for fault current. Bonding conductors connect different metal parts together to ensure they are at the same electrical potential. In your situation, the ground wires in the conduits are primarily serving as equipment grounding conductors. To clarify the recommendation, using 8-gauge ground wires in the 1.5-inch conduits for each AC unit feeder is appropriate if the feeder ampacity is less than 65 amps. For the 3-inch conduit connecting the 10 ground wires, a 6-gauge ground wire is recommended. This 6-gauge wire acts as a common grounding electrode conductor, ensuring that all the individual ground wires are effectively connected to the grounding system. This configuration helps meet grounding and bonding requirements, while also providing an adequately sized ground wire for the overall system. In summary, firstly, ensure that you understand the difference between grounding and bonding. Grounding provides a path for fault current, while bonding ensures electrical continuity. Secondly, determine the appropriate ground wire size based on the ampacity of the AC unit feeders and NEC table 250.122. Thirdly, minimize the number of conductors in a conduit to prevent overcrowding and ensure adequate heat dissipation. Finally, follow the recommendation of using 8-gauge ground wires in the 1.5-inch conduits and a 6-gauge ground wire in the 3-inch conduit for connecting the 10 ground wires. Remember to consult the NEC and local electrical codes for specific requirements in your area. The NEC is a comprehensive set of standards that provides detailed guidelines for electrical installations. Local codes may have additional requirements or modifications to the NEC, so it's essential to be aware of them. Proper grounding and bonding are essential for electrical safety. They protect people from electrical shock and prevent damage to equipment. If you're unsure about any aspect of grounding and bonding, it's always best to consult with a qualified electrician. Electricians have the knowledge and experience to ensure that your electrical system is safe and compliant with all applicable codes. When working with electricity, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Turn off the power to the circuit before working on it. And never work on electrical equipment if you're wet or standing in water. Electrical safety is paramount. It's not worth risking your safety to save time or money. Taking the necessary precautions can prevent serious injuries or even death. Remember, electricity is a powerful force that must be respected. If you're not comfortable working with electricity, leave it to the professionals. A qualified electrician can handle any electrical task safely and efficiently. They can also provide you with valuable advice on how to maintain your electrical system and prevent problems from occurring. Proper grounding and bonding are just one aspect of electrical safety. There are many other factors to consider, such as proper wiring, overcurrent protection, and surge protection. A comprehensive electrical safety plan should address all of these factors. By taking the time to educate yourself about electrical safety, you can protect yourself, your family, and your property from the dangers of electricity. Stay safe and always consult with a qualified electrician when in doubt. Furthermore, let's discuss some additional considerations for grounding and bonding. When dealing with multiple AC units, it's important to ensure that each unit is properly grounded and bonded to the building's grounding system. This helps to minimize the risk of ground loops, which can cause noise and interference in electronic equipment. A ground loop occurs when there are multiple paths for ground current to flow, creating a circulating current that can induce voltage in nearby conductors. To prevent ground loops, it's important to use a single-point grounding system where all ground wires are connected to a common grounding point. This helps to ensure that there is only one path for ground current to flow, minimizing the risk of circulating currents. In addition to grounding and bonding, surge protection is another important aspect of electrical safety. Surges are transient overvoltage events that can damage electronic equipment. They can be caused by lightning strikes, power grid switching, or even the starting and stopping of large appliances. Surge protective devices, or SPDs, are designed to protect equipment from surges by diverting the excess voltage to ground. SPD are typically installed at the service entrance of a building, as well as at individual equipment locations. When selecting an SPD, it's important to choose one that is rated for the voltage and current of the electrical system. It's also important to choose an SPD that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Regular maintenance of the electrical system is also important for ensuring safety and reliability. This includes inspecting wiring for damage, testing ground fault circuit interrupters, or GFCIs, and replacing worn or damaged components. GFCIs are designed to protect people from electrical shock by detecting ground faults. They are typically installed in bathrooms, kitchens, and other areas where there is a risk of exposure to water. GFCIs should be tested monthly to ensure that they are functioning properly. Another important aspect of electrical maintenance is keeping the electrical panel clean and free of debris. Dust and dirt can accumulate in the panel, causing overheating and potentially leading to a fire. The panel should be cleaned periodically with a vacuum cleaner or soft brush. When working on electrical equipment, it's important to follow lockout-tagout procedures. Lockout-tagout is a safety procedure that prevents equipment from being accidentally energized during maintenance or repair. It involves disconnecting the power to the equipment and attaching a lock and tag to the disconnect switch. The lock and tag indicate that the equipment is being worked on and should not be energized. Only the person who placed the lock and tag should remove them. In addition to following lockout-tagout procedures, it's also important to use the right tools for the job. Using the wrong tools can damage electrical equipment and increase the risk of electrical shock. Always use insulated tools when working on energized circuits. And never use metal tools on electrical equipment unless they are specifically designed for that purpose. Proper training is essential for working safely with electricity. Electrical workers should receive comprehensive training on electrical safety, grounding and bonding, and surge protection. They should also be trained on lockout-tagout procedures and the proper use of electrical tools. Training should be ongoing to keep workers up to date on the latest safety practices and technologies. The electrical industry is constantly evolving, with new technologies and safety standards being developed all the time. It's important for electrical workers to stay informed about these changes and to adapt their work practices accordingly. By staying up to date on the latest electrical safety practices, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. By following safe work practices and taking the necessary precautions, you can protect yourself and others from the dangers of electricity.